Okay, it's 16.2, polar equations. Wait a minute, we never did equations. We did polar points. Well, that's the difference. Let's talk about polar points. If you would please draw me a big bullseye and tell me where would 3 comma 3 pi over 4 be? I hope you remember that's a radius, an r, and a theta. A radius and an angle. Just to make sure you are putting that in the right spot, would you turn it my way? I'll tell you if you're doing it right or not. No. Oh, wait a minute. Just draw the little ray to it. Draw a little ray from the origin out to it. Even though the dot is the only thing you really need, the ray is helpful to me. Yes, that's it. Yep, 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 yep. Yep, yep. Put a dot where it ends. Good, good. Because the dot is the most important point. Yes, yes, yes. I can't read that. Can you just tilt it? It's a glare thing. That's it. That's the right spot. Good. Okay, good. Now, if pretty much everybody had this right, 3 pi over 4. I don't like that line. I'm going to try again. It's supposed to be a 45-degree angle right there, right? Okay, also known as pi over 4. And this is 3 pi over 4 is right there. And this is our dot, and we'll just label this as a length of 3. You with me so far? So what is the actual graph? It's just a dot. It's just that. It can make a triangle, but it's just a dot because that's just a point. Do you get that this also could be described in terms of x and y, as in rectangular coordinates? That's the main goal for today, is to teach you how to take points from polar and make them into rectangular coordinates, as in x comma y, as in this distance and this distance, which really isn't too bad because, think about it, it's a right triangle where you know an angle and you know a side. Yes, sir. I did teach you that. You remember how I pre-teach? I pre-taught you this the other day. So you're going to be, this won't be too tough. But it's not just changing points, it's also equations. Okay, so the point part I got you ready for last time. So would you tell me, if this side is x, just start by finding x. Write me an equation using something smart with trig. Sine, cosine, or tangent of something involves x and 3. Raise your hand if you think you know what I was talking about. Mr. B, tell me what you thought. Cosine of 45. X over 3. Perfect. Would you solve for x, please? How would you do that?
I would multiply cosine of 45 by.
I agree. Now, do we happen to have cosine of 45 memorized? Excellent. 45 is like this. Wait a minute. I should probably draw it the same way that this triangle is. 1, 1, square root of 2. Does that remind you of the 45, 45, 90? So what's cosine of 45? So this is really 3 times 1 over square root of 2. So therefore 3 over square root of 2. Raise your hand if you would have got that right. Okay, good. Now I need you to understand something. What we just did was an equation where x was equal to r times cosine of the angle. That is the general form for what x will always be. You don't have to draw the whole triangle out. Let me show you another one. So don't draw this. I know that's actually making it more difficult, but don't draw this. Now, if I have, would you agree that that's polar coordinates? Okay, it's an r and a theta, right? Then, if I want the x of it, the x is always going to be r times cosine of theta. In this case, that would be what times what? 2 times cosine of pi over 6. And then what's the other generic form for the other one? Take a wild guess. What would y equal? If cosine has always been connected to x, what's always been connected to y? Sine, and therefore what? R sine theta. You got it. Okay, now I'm about to show you a picture. It is a very powerful picture. It is not the Mona Lisa, and it's not Battleship. It's that. That can answer every question on your next test if you know how to use it, because it contains so much powerful information. Now let's just think about it. Do you get that that blue ray is kind of like the ray that would lead you to the point in polar? Let me make a big red dot here at the end. That would be the polar point. Also would be the xy, also known as what's called rectangular coordinates. That's the same old graph as we learned on Friday. That what was her name again? Miss Gomez was singing about. So sick of that same old graph. This is the old system you've been using forever. It's called rectangular. This involves polar. Do you get this is kind of a melding of both? It's like an alien and a human having a child, and it's got both parts. Too far? Okay, fine. So then tell me, what's something that'd be true about this triangle? Just say something you know would have to be true. Some things you know about right triangles. Yes, sir. Yes, this is true. I can't argue with that. But that's not an equation. Give me something that I can write down. Yes. Exactly. Give me something else that would be a true. And by the way, we're going to use that one today and many, many, many times. And on your test, you'll use it multiple times. X squared plus y squared equals r squared. What's good about it especially is that it's got rectangular on the left and polar on the right. It's kind of like the mullet of math equations. Party in the front? No. No. Business in the front, party in the back. Okay, so this one, really, really a good one. Who could find me another equation that they know would have to be true about this triangle? I bet you if you can say it, it's probably one of the big ones. Sine of theta is equal to y over r. But the problem here, you're right, nothing wrong with it. It's just that it's not got them separated into one side's rectangular, one side's polar. What could you do that would make it that way? Yes, sir. Let's just rearrange it. Just rearrange this. Times by r on both sides. And what just happened? Y is equal to r sine theta, just like we just said a second ago. So if you ever forget that point that I just gave you, the x, you're going to forget it because you're not writing anything. Write this right now. X and y can be found from this picture. We just did sine. Let's do cosine. Cosine of theta equals x over r. But it's got a kind of a mixture of polar and rectangular over there. Not so good. Fix it, Mr. O. There you go. Now it's got rectangular on the right, polar on the left. So now I can fill out my little thing here. It asks me, what's x equal to? I know now. X is equal to r cosine theta. And y is equal to r sine theta. And if you just remember sine was y, we just have to throw in one more little piece. And that why was sine y? Because r was always equal to what before? R was always 1 before. Do you notice that our r's are not just 1 anymore? Our r's are a big part of polar. R can be anything. And therefore, we have to include that. Remember how sine was always y? It was really y over 1 because the radius was always 1. It was really y over r. I did tell you back then that that would come back. And now it's back. So if you could memorize these two, that would be really important. You could memorize that, that'd be really important. But do you get, I've told you many times, you're visual people. People are really good at remembering things that are visual. And this is a picture, and a picture's worth 1,000 words, and in this case, a picture's worth like at least 7 equations. We're not done yet. We got sine, we got cosine. What did we leave out? Yes, sir. Say it. Tangent of theta equals y over x. And that one is already divided with polar on the left and What? Rectangular on the right. Okay, so all these little equations that I just wrote on the board all came from that one little picture. And they're going to be really handy. What you just got introduced to is points. You have a point, and in the old days, when you learned enough points, your teacher eventually stopped talking about points and started talking about what? Lines, and those have what's? Equations. So in the old days, you might have had the point, 2 comma 3 and 3 comma 4 and 4 comma 5, and then the teacher would say, okay, well, now we can write it something that'll give us all those points, and it's an equation. It would have x and y in it. Now we're going to make polar equations, and what are they going to have in it? R's and thetas. Just like rectangular has x and y's, polars are going to have r's and thetas. Now, in these, then, the typical equation might look like this. Do you get how that would be a typical, pretty normal equation? Or sometimes you'd solve it for y, so you move this over, and you'd have, x plus 7 or negative x plus 7. Okay, you'd have x's and y's in your typical rectangular equation. But was it also true that you could just have an equation as simple as x equals 3? That is an equation, isn't it? You can graph it, right? And you could graph just y equals things. Same thing with polar. On polar, you can have an equation that has r is equal to sine theta. It's got an r and it's got a theta, just like this has an x and a y in it. This has an r and a theta in it. Or I could have a polar equation that's just like this. Think about how that would look. What do you think? It would be a circle with a radius of 7, because it's like you didn't tell me the angle, so it's every angle. The distance is 7, and so it's a radius of 7 all the way around. My circle is terrible, I know, but that's okay. Now, I'd like you to just think about this a little further. Do you remember that r squared was equal to something? X squared plus y squared, right? Remember that other sheet we just had up 2 seconds ago? X squared plus y squared is equal to r squared. All right. If you're having trouble with your memory, it might have something to do with this. All right. If radius is 7, and seconds ago I told you that x squared plus y squared is equal to r squared, wouldn't it be handy if that was just r squared? Well, can't you just make it squared? Couldn't you square both sides of the equation? Yeah, these equations act just like normal x plus y equations. If I wanted to square this, I could square this on both sides if I wanted to. I can square this on both sides if I want to. So that's r squared equals 7 squared is 49. And then, what's r squared equal to? X squared plus y squared. So I can now change this to x squared plus y squared equals 49. I hope that looks familiar. It's the equation of a circle. How many of you remember that from higher algebra? All right, if you forgot it, I'm going to take 2 seconds on this because this is actually an ACT topic. X plus 3 squared plus x minus 4 squared is equal to 144. Say that's on the ACT. Will you be able to tell me the center and the radius? Who in here can tell me the radius at least? All right, Mr. T? Radius would be 12 because it's like 12 squared right here. Like x squared plus y squared, or sorry, a squared plus b squared equals c squared. All right, so yeah, the radius of this thing is 12. And what is this telling me right here? The center. It's like the origin was the original parent function, but this got moved 3 to the left. And what's that? Careful. Down 4 or up 4? It's on the inside of a parentheses. Up 4. This means left 3, just like you would expect it to, because it's on the inside where x usually is. Y normally isn't in parentheses. You normally could trust the y numbers, and you'd say, oh, down 4. This one's up 4. So the circle has a radius, or a center at left 3 and up 4. Its radius was 12. That's just 2 seconds on a little ACT stuff for you. All right, so now, what does a typical question look like for today? Well, let's actually let's just dive into the homework for today. Given where we are in the lesson, I'm feeling like we could start. Find that. Pause for a second. Here is a review of yesterday. It's giving me a negative radius and a negative angle, and you just got to find what the other ones are. Like here's one where they want a negative radius but a positive angle. Here's one where they want a positive radius and a negative angle. And then on this last one, etc. We practiced that already. You should be good with those. They're only doing the ones that are circled. If you do all the circled ones, that's 13 questions for today. So I'm going to do a few of these with you, but those are a little too easy. Sometimes this freaks people out. It's still in r comma theta. It's just messing with your head a little bit. Couldn't the radius be 2 times 3.14? Couldn't the radius just be 6.28? Yeah, it's just saying the radius in a funky way to mess with your head. The r is still always first. All right, moving on. These two are convert from polar into rectangular. Who remembers, without looking, what x is? Yes, ma'am? R cosine theta. Do we have r? Yeah. Do we have theta? Yeah. You'll just have to figure out what cosine of theta is. That's the only hard part. So make yourself a little picture, figure out where 7 pi over 4 is. Hint, here's 4 pi over 4. 5, 6, 7 pi over 4 is like that. You'll have to figure out, oh, this is 45. So this is a 1 square root of 2. And then you can do cosine of 7 pi over 4. All right, but you might want to write this one down because not everybody had that memorized. R cosine theta. Hopefully you'll get some sleep tonight and this will set into your brain. What's the y then? R sine theta. Because sine goes with y just like it used to. That make sense? All right. We already have r, it's 5. We already have theta, it's 7 pi over 4. Once I figure out sine of, actually the same triangle can be used for both this one and that one. It'll make it go a little faster. All right. If all else fails on this, draw a picture. 2 comma pi over 3. Here's, I can say that that's 2. And then I can say that this is 60 degrees. Can't you figure out the x and the y from that? Sure. It's slower, but you could do it that way. But I think it's better to memorize that x is r cosine theta. Drawing a picture is good, but it'll be slow in the end. And those other little things we memorize are going to help for things like this. Remember how in the rectangular system you have x's and y's? But what if we want to change that to polar? We know what x is. We just wrote it down seconds ago. Replace x with what? R cosine theta equals -3. Now, some people are bothered by this because it has both variables. Don't most equations have an x and a y in them? You know, y equals blah, 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 x. Isn't it okay to have both in them? Yeah. So it's okay to have both r and theta, but it sometimes tells you to solve for one of them. Notice in the directions, what does it say to solve for? It says solve for theta. Well, first let's get the r to the other side. Okay, I'm almost done. This already has, instead of x's and y's, it has r's and thetas in it. So then I'm going to divide by r. Oh, it's only in 60 through 63. Okay, cool. Thanks for reading the directions. It only says in 60 through 63 you need to solve for theta. All right. So this one, do you know what y is? I have it memorized. If you don't, go back a page. You'll see y is equal to blah, blah, blah. Do you know what x is? I have it memorized. And then when you're done, notice it wants you to solve for theta. All right, so let's work this a little bit further. What's y? R sine theta equals what's x? R cosine theta times square root of 3. And it wants me to solve for theta? All right, first hint. This is solving trig. You had it on your last test. It's not like it's new. You want to get this to be one function only. Hint. Sine and cosine can together make one function, can't they? Tangent. Okay, so how could I get this to be sine over cosine? Divide both sides by cosine theta. Why was that smart? Not only does this cancel, now I have, what's that? Tangent. Now I can divide both sides by r, and some of you are going to be disturbed that r is going to cancel like that. I'm going to times by 1 over r, times by 1 over r, and the r's will cancel the r's, and they're just gone. Is that okay? Yeah. Just like in x and y rectangular equations, you can get it down to just y equals 6. It's legal. You can get this down to just be theta. So this is tangent is equal to root 3. How do you solve that? This isn't a skip problem anyway because it isn't circled. So tangent of theta, yes, graphing does work, but you could graph both sides and see where they cross. But if you're just trying to get theta alone, what gets rid of tangent? Yes, sir. Inverse tangent. Inverse tan on both sides, and inverse tan cancels tan. Theta is equal to inverse tan of root 3. Now, that was the hard way to solve it. I want you to refer back to that little picture we had, and it was x and y and r. And I want you to think with me for a second. What was the statement about tangent that we had? Say the whole thing. Tangent of theta equals y over x. Could we have gotten y over x in this equation and then just substituted in tangent? You see how much quicker that would have been? If you didn't actually go through and show all the work yet, if I were you, how would you start to get y over x? Divide by x. And you'll have y over x is equal to square root of 3. And the y over x, clearly, is equal to tangent. So you can just swap it for tangent, and we'd end up with the same thing. We'd end up with the tangent of theta is equal to square root of 3. You do still have to know how to use inverse to get the theta alone, but that's 2 ways to solve that. Yes, sir.
Inverse tan and arc tan.
Yes. The only argument I've heard about arctan being different than inverse tan is that arctan is clearly calling for an arc and therefore wants radians for sure. And inverse tan, it's legitimate to give a degree answer. Okay, so this little nugget is especially helpful. Let's go through other little nuggets that you might need to know. Like for these problems, do you get that R is not easily solved for in rectangular? Here's that fact thing again. X, Y, R. X squared plus Y squared is equal to R squared. R squared is easily solved for. So how can I make an R into an R squared? Square it. What's another way, though? I know you know that that'll work on this one. We already talked through that one. What's another way to make R into R squared without having to square it? I know you're going to say this is cheating, but if I times by R, right? Now let's just walk through that for a second. What if I had R and I just squared it? I'd have R squared equals 49. What if I times by R on both sides? Is it going to be different? R times R is equal to 7 times R. That is different, isn't it? So timesing by R on both sides is a good strategy. So is squaring both sides. You just got to pick when to use what. Okay, this one would actually work. R squared is equal to x squared plus y squared. And now the problem is I haven't got it solved all the way. I'd have to do more. What's R equal to? So then I put a 7 right here. And I have 7 times 7. And I have 49. So it's still going to work. I'm just warning you that squaring both sides doesn't always work. So multiply by R in your back pocket. Also, if you see something like this, there's a hard way and an easy way. The hard way is to swap the y for r sine theta and the x for r cosine theta. That's the hard way. What's the easy way? We just did it a second ago. Divide by x on both sides. Why is that smart? Because that's tangent. No. Oh, wait. Is it y over x? Sine's what? That's tangent. That's tangent. If it had been upside down, you're right. But we want to do it in such a way that we always have y over x. So I could see a kid making the mistake and going, I'm going to divide both sides by y. And then they cancel this and they think that's tangent. That's not. That would be cotangent. It actually could still work, but it's a pain in the butt. All right. You've learned a lot. Believe it or not, we still have a few minutes to spare. So I think we have time to let you work on your homework. If you need help, come on up and ask. I didn't do any preview of graphing. Feel a little bit bad about that, but graphing's coming tomorrow. You'll need your graphing calculator. You know what? I'm going to give you a 2-second preview of it. If you had to graph this for the first time, I bet your teacher made an XY chart. Didn't they? And then they said, well, let x equal to 2. What does y have to be? 2. Stick in anything you want for x. I'm going to put in 0. You get 0, and you realize, oh, those are points. So our theta table is the new xy table. So when you're graphing polar, you just pull some points and go, okay, I can let r be, well, what does r have to be? 7, and theta can be any angle I want. So what's 1 point on this graph? 7 comma pi over 3, pi over 6, pi over anything, doesn't really matter. 7 comma pi, 7 comma 2 pi over 3. I mean, it doesn't really matter. You can have any angle you want. Okay, here's another one that's a little less easy. Does this have an r and a theta in it? Then it's a polar equation. Can I make an r theta chart to figure it out? Sure. You can pick anything you want. What would be smarter? Picking r's or picking thetas? Thetas. What are nice thetas to pick? 30, 60, keep going. 45, 90s, maybe 180. Okay, let's just do one of those. Let's say 30, also known as pi over 6, right? What's cosine of 30? You might want to draw one of these. And then you go, what's cosine of 30? Now that you got the picture, should be easy, right? What's cosine of 30? Root 3 over 2. What's that? It's a point in polar. Graph enough points, what do you get? A line, a graph. Okay? That's a preview of tomorrow. And then that's the last thing you have to know. And then Wednesday, we review. Thursday, test. Yes, you can call it a line. It is a line. It's a curved line. Yeah, they are kind of spirally, but they're still lines. But it is not a linear graph. Linear would imply only a straight line. But all right, that's all I got for you for today.